In this video, I will show how I modified the SR540 roaster to work with an extension tube and the Artisan software. This video is based on concepts described in 3 previous videos shown here. You can find links to these videos in the description below. It might be useful to watch these videos before this one if you have not done so already. First, let's talk about the advantages of roasting with an extension tube. The first one is improved beans movement with lower supply voltage, leading to a more even roast result. The reason why the extension tube helps with beans movement is because it has a smaller diameter than the regular bean chamber, resulting in approximately 60% higher air velocity for the same airflow. The math is shown here if you are interested. This higher velocity compensates for the lower airflow produced by the fan at lower voltages. In the US and Canada, the supply voltage could be as low as 114 volts and as high as 126 volts. You can easily measure the supply voltage at your home with a device like the one shown here. See the link in the description below for more details. The demo roast shown later in the video was done with a supply voltage of 124.6 volts, near the upper range of supply voltages. At my home, I typically see supply voltages in the range 116 to 125 volts. When the supply voltage is in the low end of the range, as shown here with a voltage of 117 volts, even at the highest fan setting of 9, the air velocity could be too low to provide adequate bean motion, especially when starting the roast because the beans are heavy before they start losing moisture. With a higher air velocity in the extension tube, the beans would have adequate motion from the start, resulting in a more even roast. The second advantage of the extension tube is that you can increase the amount of green beans from 4 to 4.5 ounces to 6 to 8 ounces, as long as you upgrade the chaff collector as described in this video. Here, I want to make an important disclaimer. The SR540 roaster manufacturer does not recommend exceeding 4 ounces of green, wet, processed beans. Going above this amount may plug the chaff basket and cause a fire. The chaff collector modification I will describe in this video may avoid this problem, but I do not guarantee it. If you increase the bean weight beyond the recommended amount, do so at your own risk. Make sure to empty the chaff collector after each roast and make sure it is not plugging during a roast. If it plugs, start the cool down cycle immediately. I was able to roast up to 8 ounces of green beans in the SR540 with the extension tube and the chaff collector modification, but this is my experience only. I have routinely roasted 6 ounces of a variety of green beans without any issues and the chaff collector never plugged, but again, this is only my experience and not a guaranteed result. So here are the 3 modifications I made to run the SR540 with an extension tube and the Artisan software. I will now address each one of them in some detail. I purchased the extension tube directly from the roaster manufacturer. The link is provided in the description below. I then assembled the tube following the instructions that came with it. Here is where the manufacturer warns that going above the design amount of green beans may cause a fire. I found a solution to upgrade the chaff collector so I can increase the amount of green beans from Ratso Roasting at Etsy. See the link in the description below. Unfortunately, when I checked, the kit was not in stock, so I decided to make my own. Last time I checked, it was in stock, so I would recommend to buy it directly from Ratso Roasting. An extension tube is also available from this supplier, but it is not always in stock. I cut some mesh approximately to the dimensions of the kit using strong scissors. Then I installed the mesh inside the chaff basket as shown here. The mesh height is longer than the basket wall, and the chaff collector lid just rests on top of the mesh. Here you can see the gap between the chaff lid and the basket covered with a mesh. This gap provides an additional large venting path for the air exiting the roaster. Also, inside there is a gap between the lid and the basket center, providing an additional path for the chaff to get inside the chaff basket. This additional path makes the chaff collection and air venting much better. The main problem is that the lid sitting on top of the mesh is not as stable as the original system, so you have to be careful. But the chaff collection works very well. Here you can see the chaff collected after a 6-ounce roast. With a gap between the lid and the top of the inner basket wall, the chaff will easily get into the basket, but so will the coffee beans. You have to be careful that the fan setting is not so high to have beans flying to the top of the extension tube, or beans will start collecting in the basket. The Razor roasting kit has an additional mesh to avoid this problem, so that is another advantage of purchasing the kit. Okay, now the third and final modification I made to my roaster was to add a longer bean thermocouple. I had already modified the roaster with 2 thermocouples as described in a video linked in the description, but the bean thermocouple was too short for the extension tube. I purchased a 30 cm long 4 mm diameter thermocouple shown here and with a link in the description below. Now the new thermocouple was too long, so I improvised an adjustable stop as shown here with 2 plates, screws and nuts that I already had around. I adjusted the length from the adjustable stop to the tip of the thermocouple to 23 centimeters or 9 inches. The problem I ran into was that the lid hole I drilled before was intended for the thermocouple neck and it was too big for the 4 mm thermocouple body. So here is the issue. The bean thermocouple was too loose and the roasting beans would move it around. To fix the problem, I improvised the shim solution using a paper clip and hammering the tip to make it flat, as shown here. I then pushed the tip of the pin in the space between the thermocouple and the hole to shim the gap. This was sufficient to stabilize the thermocouple. This is how the pin shim looks installed. You may come up with a better solution or drill the right size hole to begin with. One more detail. The terminals for the thermocouple I bought are not compatible with the fidget module connections, but I simply bent one of the legs to make it fit, as shown here. The environment thermocouple works exactly as shown in the previous video, and there is no need for any modifications. The long bean thermocouple makes it more awkward to remove the chaff collector to empty the beans when the roast is done. To help, I have a tall container next to the roaster as shown here, so I can move the chaff collector with the thermocouples in and out of the extension tube more easily. So this is how the setup looks like. For the sound, I found after I made this video that it is better to have the microphone higher because the double glass wall at the bottom of the roaster attenuates the high frequency noise of the cracks. I use a laptop running Artisan and Audacity as described in previous videos linked below. Check these videos for details about the interface and configuration of these programs. The only Artisan configuration setting I changed was the filtering on the beans thermocouple. The new thermocouple is thicker than the old one, 4 mm versus 3.2. This means that it responds a little slower to temperature changes, so less filtering is needed. I found the same filtering setting for both thermocouples work well. This is minimal filtering because I like the reading to be very responsive, but you may find it too noisy. In that case, you can increase the filtering if you wish. For the roasting demo, we're going to load 6 ounces of Primos green beans. See the link in the description below for details about these beans. The beans are in the extension tube and we're getting ready to start the roast. I started the roaster and then pressed the charge button. You can see how I arranged the layout of the Artisan and Audacity program on the computer screen area, so I can check both of them at the same time. I started the roast with a fan setting of 9 and a heat setting of 1. This is to slow down the drying phase and promote uniform bean temperatures. As a reminder, the sliders are not controlling the roaster fan and heat settings. I need to remember to adjust the sliders after I manually change the roaster settings to keep a record in the lower half of the display. You can see that the beans right away have good movement in the extension tube. In fact, as the beans warm up and get lighter, you have to be careful that they do not fly too high and run the risk of getting trapped in the chaff collector. For this reason, when I need to increase the heat, I lower the fan setting rather than increase the heat setting, and I keep lowering the fan setting until the bean's movement is adequate but not excessive. Only after that, I start increasing the heat setting if needed. Even with the highest fan setting and the lowest heat setting, the bean's temperature is quickly increasing, so the drying phase is usually over in less than 3 minutes. As another reminder, the blue curve is the bean temperature thermocouple reading and the red curve is the environment thermocouple reading. Here are the current temperature readings for each thermocouple, and here is the corresponding rate of change in Fahrenheit per minute, shown on the right scale. Soon, the rate of change will enter the scale range and will be visible on the plot. Here you can see the rate of change curves showing up. We will be using these curves to adjust the roaster fan and heat setting. As the bean temperature reached 300 Fahrenheit, we press the dry end button to indicate the end of the drying phase. After pressing the dry end button, Artisan starts showing an estimate of when the first crack will start and how many minutes to this event. These estimates will keep changing as the rate of change changes. The rate of change is coming down quickly, so I reduce the fan settings to 8 and adjust the slider accordingly. A record is made of this change here. As a result of this change, you now see the rate of change increasing. We're now in the Maillard phase of the roasting. I don't want to rush through this phase, and I will try to have a slowly declining rate of change. As you will see, this is not so easy to accomplish with the SR540 roaster, but on average, it should be okay. You will see that the rate of change curves are a little erratic, and sometimes the bean thermocouple rate of change and the environment thermocouple rate of change show opposite trends. I think this is because the mass of beans interacts with the warm air, causing local temperature perturbations. Also, the temperature change around ET lags the temperature change around BT a little bit. I see the rate of change going down, so I will lower the fan setting to 7 before it goes down too much. As a result of lowering the fan setting, the rate of change now starts to increase. You can see that the change of 1 unit in the fan setting caused a jump in the rate of change of approximately 10 degrees Fahrenheit per minute. It then quickly started coming down, so I lowered the fan setting to 6. The beans are still moving a lot with a fan setting of 6, so I will keep lowering the fan when I need to increase the rate of change. Note that the heat setting is still at the lowest level of 1. Fan and heat setting changes depend on many factors, for example, supply voltage, outside air temperature, beans type, and beans weight. This is why it is not possible to have a general recipe that will work in all cases, and having the artisan feedback is very helpful to know when to change settings. You can see that after a fan setting change, the rate of change jumps by 10 degrees per minute or so. So you cannot control the rate of change very precisely and need to be careful not to change the settings too early and then overshoot. Now the rate of change is falling quickly, so I lower the fan setting to 5. If I had kept the original fan setting of 9 and used the heat settings instead to control the rate of change, by now the lighter beams would be flying into the chaff collector basket. This is one of the things you need to be careful with the extension tube. We are now approaching the start of the first crack. Watch the sound waveform for crack spikes. And here is the first one, and more coming. I press the first crack start button to indicate this event. The rate of change started dropping fast, so now I increased the heat setting to 2. I think I could have lowered the fan setting to 4 instead. The beans are still moving too much. You can see the beans motion in more detail here. At times, the beans get very close to the top of the extension tube, so they are at risk of getting trapped in the chaff collector. Another problem with the beans getting too high in the extension tube, I think, is that the temperature there is approximately 40 Fahrenheit cooler, so the beans are subject to a rather large change of temperature as they go up and down the extension tube. I am not sure how much this temperature fluctuation can harm the quality of the roast, but just in case, it's better to avoid it. So in general, I try to keep the beans moving, but not much higher than above the middle of the extension tube. So in this roast, I should have probably kept lowering the fan setting, maybe 2 more times before starting to increase the heat setting. By now, first crack has ended, and we could stop the roast anytime, depending on the desired roast level. For a pour-over coffee such as V60 brewing method, we could stop here, for example, or even earlier, depending on how much origin flavor you want to taste in your cup. For this roast, I plan to start the cool down soon after the second crack starts. This will be a CT Plus roast, a roast level I enjoy for espresso. A few seconds ago, I increased the heat setting to 3 to keep the rate of change from falling too much. I mostly look at the blue bean thermocouple rate of change to decide when to change settings, although sometimes I use the red environment thermocouple rate of change to confirm a downtrend. Timing the adjustment takes some getting used to. If you do it too soon, then you will overshoot and the rate of change will increase too much. But if you wait too long, then you will undershoot and the rate of change will decrease too much. You never want the rate of change to become negative. We're getting close to the start of the second crack, and we start paying attention to the sound waveform for spikes. And here is one. We push the second crack button to indicate this event. As mentioned in a previous video, after the roast, we will look at the recorded waveform and adjust the timing of events as needed. I now push the cool down button on the roaster to stop the roasting. I'm going to fast forward the 3-minute cooldown phase because there is not much happening here. The cooldown is now complete and I press the off button. Here you can see the beans in the extension tube at the end of the cooldown cycle. And here is a close-up view of the roasted beans. I think the result is a nice, even roast. One more thing before finishing the video. I will use the recorded sound waveform to adjust the crack event's timing more precisely, as I showed in the sound analysis video. For details of this procedure, please see the link in the description below. Here is the raw recorded sound waveform captured during the roasting by Audacity. And here is the sound waveform with the Audacity noise reduction effect applied to be able to see the crack spikes more clearly. The timing also has been synchronized with the Artisan timing as explained in the previous video. I obtained the timing of the main events using the process sound waveform in Audacity. Here I show the results. I then typed these values in the Events tab of the Roast Properties menu in Artisan. And here is the adjusted final version. First crack starts at 397 Fahrenheit and ends at 425, and second crack starts at 448 Fahrenheit. I can then use this information to plan the next roast using these beans. For example, if for my next roast I want to stop just after the first crack for a city roast, then I should plan to start the cooldown cycle at around 425 degrees Fahrenheit. Thank you very much for watching, and I hope you found some useful information.